Circular motion. Introduction. Circular motion is the motion along the circumference of a circle. If the particle moves from A to B, then V is equal to S upon T is average speed of the particle. The position vector gives the position of the particle with respect to observer O. In this chapter, we will learn about basic concepts of velocity and acceleration, banking of rods, centripetal and centrifugal force, and conical pendulum. Explanation. Angular displacement. It is defined as the angle traced out by the position vector of the particle in that interval of time. Angular velocity. It is the time rate of change of angular displacement. Angular acceleration. It is the time rate of change of angular velocity at that instant. Relation between linear and angular velocity. Consider a particle moving in a circle of radius r. The linear velocity r is equal to ds upon dt. We know that ds is equal to d theta multiplied by r. Dividing by dt, ds upon dt is equal to d theta upon dt multiplied by r. V is equal to rw. Radial acceleration. The linear velocities Pq and Ca is equal to v. Take a point A and draw vectors Ca and Cb. Join AB. By triangle law of vectors, Ca plus AB is equal to Cb. A bar is equal to dv upon dt and angle ACB is equal to angle POQ is equal to delta theta. AB is equal to delta V is equal to V delta theta. A is equal to dv upon dt is equal to V delta theta upon delta t is equal to VW. W is equal to V upon R. Therefore, A is equal to V square upon R. Centripetal and centrifugal force. The force of magnitude is equal to mv square upon r, which is directed towards center of circle, is called centripetal force. The force which is of magnitude mv square upon r and directed away from center is called as centrifugal force. It is a pseudo force. Banking of rods. Raising of the outer edge than the inner edge is called as banking of roads. For a vehicle moving along the road, there is a force of gravity acting downwards. Normal reaction N upwards. The normal reaction can be resolved into two components, N cos theta and N sin theta. N cos theta balances mg, while N sin theta balances centripetal force mv square upon r. Therefore, N cos theta is equal to mg, N sin theta is equal to mv square upon r. Therefore, tan theta is equal to v square upon rg. Theta is equal to tan inverse into bracket v square upon rg bracket complete. Conical pendulum. A pendulum moving along a circular cone is called as conical pendulum. Consider a pendulum moving along the circle of radius r. The forces acting on the bob are its weight mg and tension T. The tension T can be resolved into two components, T sin theta along horizontal and T cos theta along vertical. T cos theta is equal to mg, T sin theta is equal to mv square upon r, tan theta is equal to v square upon rg, v square is equal to rg tan theta, T is equal to 2 pi r upon v, or T is equal to 2 pi r upon square root of Rg tan theta. T is equal to 2 pi square root of R upon G tan theta. T is equal to 2 pi square root of L cos theta upon G.